Alright, we're in the second video in Chapter 9, and we just talked about what a mole ratio it was. A mole ratio in a balanced chemical equation is the coefficients or the quantities of reactants and products compared to one another. And we're going to use mole ratios to solve stoichiometry problems. Meaning, if we're given the quantity of one reagent, we want to figure out what the quantity of the other reagent is. So, what do I mean by this? Let's suppose we have a really simple reaction. The reaction is A goes to B. And actually, let me put this on the bottom here. We have reaction A goes to B, whatever A and B are. And if this is a balanced chemical equation, there will be coefficients. So we'll say the small letters here are the coefficients of A to the coefficients of B in a balanced chemical equation. Alright, so A is a reagent, it's a reactant, and B is the product. Let's say we're given a quantity of A. If we're given a quantity of A in moles, so where we know we have moles of A, let's say we want to calculate how many moles of B we would like to produce. If I'm given quantity of A in moles, and I want to calculate quantity of B in moles, then the ratio that I'm going to use, or the conversion factor, is the units between those two. So I'm going to use a mole to mole ratio. Also, by this book, we call it a mole ratio. It's the same thing. If I say mole to mole ratio or mole ratio, no, it's the same exact thing. Alright, that's going to be the quantities of the coefficients of the balanced chemical equation. Alright, now this is what we just did at the end of the last video. It was pretty simple, right? Alright, it is pretty simple. The way that it can be made just slightly a little bit more complex is that instead of being given a quantity in the mole unit, what if you were given the quantity of A in a different unit? Like in grams. What if I was given grams of A and asked to calculate moles of B? If I was asked to calculate moles of B and I was given grams of A, in order to calculate the quantity of B, I still have to go through the mole ratio. But before I can convert to moles of B, I need to convert grams of B into, or grams of A, into moles of A. Because I must always go through the mole. The mole is the central unit in chemistry. So in order to convert from one reagent to the other, from A to B, I must still always go through the mole. So if I'm given the quantity of A in grams, I have to convert grams to moles of A first using molar mass, what we learned about in Chapter 7. And then, now that I have moles of A, I can convert to moles of B. And let's even go further. If I was given if I had calculated moles of B, couldn't I actually convert that to grams of B if I have the molar mass of B? Yeah. So if I've got moles of B, I can further convert that using molar mass to grams of B. Alright? So let's look at what we've done so far here. So if I'm given grams of A, I can convert that all the way to grams of B, so grams of my reactant to grams of product, by using three conversion factors: molar mass of A, the mole ratio between A and B, and then the molar mass of B. So in three conversion steps, I can get from grams of A to grams to B. I can also be given the quantity of reagent in a number of units. So I could be given numbers of A, like number of atoms, or number of formula units, or number of molecules of A. If I was given numbers of molecules of A, and I want to convert that to moles of A, how do I get from a number of something to a mole? I use Avogadro's number. Okay, so if I'm given a quantity that's not a mole, I must first convert it into the mole before I can do my mole to mole. And if I'm asked to calculate a quantity that's not a moles of the product, maybe it's either grams of B or the number of molecules of B, then I have to convert out of the mole. And the way I convert out of the mole would be using either my molar mass or my Avogadro's number. So we have actually a really easy way of remembering, if you have a more complex stoichiometry problem, how to solve the problem. The chemist always says, well, in order to solve a stoichiometry problem, you always have your given reagent and the reagent you need to find. You're going to convert into the mole, and then you're going to do a mole to mole, and then you're going to convert out of the mole. I'll write that down for you. All right, so it's into the mole, then do a mole to mole, then out of the mole. What does into the mole mean? If you're given a reagent, if the given reagent is in any other quantity besides a mole, you must always convert it into the mole first, using either molar mass or Avogadro's number. So this is the quantity of the given reagent. For instance, if I said I was given 5 grams of water, well, I've got to convert grams of water to moles of water. I've got to convert it into the mole before I can do the rest of the problem. So the mole to mole ratio is always converting the given to the unknown. So you would, once you have your moles of your reagent, you would always convert that to moles of the unknown. And then if you were asked to calculate anything besides moles of your unknown, what you need to find, you would convert out of the mole. So coming back here, I'm going to erase all this. Oops, that's not eraser. All right, some problem-solving strategies. Everything down here is exactly what we just talked about. It says, how do I solve a stoichiometry problem? Well, basically these steps are the 3 steps I just told you. They're just written out in formal sentences if you like to have them more that way. The first step says to convert the amount of starting substance given into moles, if it's not already into moles. The second is to use the mole ratios from the balanced chemical equation in order to convert to the moles of the desired substance, so your unknown. And then number 3, convert the moles of the desired substance into to the units specified by the problem. Basically, that means convert into the mole, either grams or numbers into a mole, calculate the mole to mole, and then calculate out of the mole. So the best way to learn this is by doing some example problems. So let's just do some problems. Alright, so here's some example problems. Hopefully you have your calculator out because we're going to get started here. The first one says, what mass of hydrogen, and it says 2.02 grams per mole, is made by the reaction of 3 moles of HCl with excess aluminum. Alright, so notice here that we have a word problem, and below we have a balanced chemical equation. This is a stoichiometry problem. What does that mean? It basically means we're going to be given the moles, or going to be given the amount of one reagent and asked to calculate the quantity of another. What unit must we always go through? The mole, which makes it a stoichiometry problem because we have to use the balanced quantity of reagents. Alright, so let's read the question again. And as we read, I'm going to mark up, just like I did on the previous video, I'm going to mark up this balanced chemical equation as kind of a solution map. So it says, what mass of hydrogen? H2 is hydrogen. So I want to know the mass of hydrogen. Mass is always in grams. So I want to know how many grams of hydrogen is going to be made, that's why it's a product, by the reaction of 3 moles of HCl. So we'll find HCl, here it is. We're given 3.0 moles of HCl with excess aluminum. Whenever you see that you have a word like excess aluminum, that basically means we're going to have enough aluminum, don't worry about it. But I want to know if I've only got 6 moles of HCl, how much product can I make? It's kind of like you walk to the fridge and you've got that cake you have to bake. Let's say that you have, for every cake, remember you need a box of cake mix, a third a cup of oil, a cup of water, and you need 3 eggs. Well, if you walk to the fridge and you've got plenty of water, you've got plenty of oil, you've got plenty of cake mix, and you only have 3 eggs, you want to know, how many cakes can I make? Because this is as much as I have. And we'll talk about what that's called later. But basically, just if you see excess of any reagent there, that means you're not going to have to worry about it. You've got a lot. You can make as much as you want, but this is the reagent you need to worry about. How much can I actually make? All right, so it says, what mass of hydrogen? Okay, so we look at what we diagrammed here, and we were given the moles of HCl, and we're asked to calculate the grams of hydrogen. So we're given this quantity, and we're asked to calculate a new quantity. Notice how I'm always drawing this bridge. What do we always have to do when we're calculating the quantity of a new reagent from another reagent? We always have to go through the mole. We always have to use the mole ratios. All right, that's an exclamation mark. Now, I didn't write down this. What is this number given here? It says 2.02 grams per mole. Well, that's the mass per mole of hydrogen. That's why it was given right after hydrogen. Hydrogen weighs 1.01 grams for every atom, so H2 is 2.02 grams. This is the mass per mole, also known as the molar mass of hydrogen. Remember, molar mass is a conversion factor, so this one's given in the problem. So we're going to use that probably if it's given to us. All right, so I'm going to go ahead and I'm going to get started. I'm going to write down what I've gotten. I'm given 3.0 moles of hydrogen, HCl, I'm sorry. So I'm given 3.0 moles of HCl. Remember that the first thing I'm going to do is I'm going to think, if I have a stoichiometry problem, if I'm given the reagent, I need to convert it into the mole. Do I need to convert 3.0 moles of HCl into moles of HCl? No. Because I'm already in the mole, I can skip to the second step, which is convert mole to mole, right? So I'm going to convert moles of HCl to moles of hydrogen. So I went into the mole, I didn't have to do that. So now I'm going to do a mole to mole, moles of HCl to moles of hydrogen. I'm going to do that using the balanced chemical formula. So let's do our mole to mole ratio. So I'm given moles of HCl, so I'm going to put that in the bottom here. Got an HCl up, got an HCl down. Those will cancel out. I want to convert that to quantity of hydrogen. So I've got to do a mole ratio to convert quantity of one reagent to another. So I'm going to put my moles of hydrogen up there. Now let's write the chemical equation, the quantities actually, from the chemical equation. For every 6 moles of HCl, I produce 3 moles of hydrogen. So I'm going to put 3 over 6 there. Our mole to mole ratio is 3 moles of hydrogen over 6 moles of HCl. Now I get this question a lot. Isn't 3 to 6 the same thing as 1 to 2? Could I write 1 mole of hydrogen for every 2 moles of HCl? You can. If you realize that that ratio can be simplified, a ratio is just the same. It's just a ratio. 3 to 6 is the same thing as 1 to 2. You could do that. However, I suggest to minimize error or accidents to just write in the numbers that are given for now. And that's what I'm going to be doing. But if you understand what that means, then you can go ahead. All right. So now I've converted from moles of HCl to moles of hydrogen gas. But I'm actually asked to calculate the mass, or the grams of hydrogen gas. So we went mole to mole, and now we're going to go out of the mole. So I'm going to convert my moles of hydrogen on top and on bottom there to grams of hydrogen. And this is a molar mass conversion factor. So I've got mass on top, moles on bottom. This is the molar mass given in the problem. For every 1 mole of hydrogen, there are 2.02 grams of hydrogen. All right, so now we can grab our calculators. I'm going to grab mine right now because I've got to do a calculation here. All right, so let's see here. I've got 3.0 times 3 times 2.02 divided by 6. Okay, did you all get 3.03? All right, I got 3.03 too. Now I started with 2 significant figures, so I'm going to put my approximants here. I'm going to round to 2 significant figures. So it looks like it's going to be about 3.0. Oops,